Welcome to Rogani College of Engineering and Technology. I am Reggie, Associate Professor, Department of ECE. In this session, we are going to see about microstrip antennas. On completion of this microstrip antenna, students will be able to define microstrip antenna, design of antenna parameter like gain, bandwidth and directivity. Microstrip antenna in high performance aircraft, satellite, miscellaneous application where size, weight, cost, performance, ease of installation and aerodynamic profile are constrained. Low profile antenna may be required. Microstrip antenna are low profile, conformable to planar and non-planar surface, simple and inexpensive, mechanically robust when mounted on rigid surface, compatible with MMIC design, and when the particular patch shape and mode are selected, they are versatile in terms of resonance frequency, polarization, pattern and impedance. Microstrip antenna, the disadvantages of microstrip antenna are low efficiency, low power, high Q, poor polarization, poor scan performance, spurious fade radiation, very narrow frequency bandwidth, which is typically only in fraction of percentage or few percentage. Basic characteristics of microstrip antenna. Microstrip antenna considerable attenuation in the year 1970. Although the idea of microstrip antenna was traced to 1953. Microstrip antenna consists of very thin T is less than lambda naught, where lambda is the free space wavelength, mechanical strip placed on the small fraction of wavelength and above the ground. Microstrip patch is designed so the pattern maximum in normal to the patch broadside radiator, which is accomplished by properly choosing the mode. End-fire radiation can be accomplished by judicious mode selection. For a rectangular patch, the length of L is usually lambda by 3 less than lambda by 2. The strip and the ground plane are separated by dielectric sheet known as substrate. In this figure, you will have the radiating slot 2 and center as the patch with the microstrip. The side view is given as the ground plane, and the coordinate system of the radiating field will be mentioned in terms of circular coordinating system in X, Y and Z plane. There are numerous substrates, and the design of microstrip antenna will have the dielectric constant 2.2 less than epsilon or less than 12. These one are more desirable for good antenna. There are substrate where dielectric constant is in lower end of the range because they provide better efficiency, larger bandwidth, loosely bound for radiation. Thin substrate with high dielectric constant are desirable for microwave circuit because they are tightly bound field to maximum undesired radiation and coupling and lead to smaller element size. However, because of greater losses, they are less efficient and relatively smaller bandwidth. Since microstrip antenna are often integrated with low microwave circuit, compressed to reach a good antenna performance. So normally if you see the different company will have different substrate which have the thickness 0.12, frequency 0.40 and 0.00. Typically substrate and the parameters. Basic characteristics of often microstrip antenna are referred as patch antenna. The radiating patch may be a square, circular or thin patch. Square, rectangular and circular are most commonly used for fabrication. Microstrip dipole are attractive because they are inherently possess large bandwidth and occupy less space. Linear and circular polarization will be achieved with a single element or array of microstrip antenna. These are the different type of microstrip patch array including square, rectangular, dipole, circular, elliptical, triangular, dissector, circular and ring sector. Microwave feeding structures are microstrip line feed, coaxial probe field, aperture coupled field, proximately coupled field. This field will have the data that is the signal given as the input to the field. First is microstrip line field. Microstrip line field is easy to fabricate, simple to match, simple to model and simple to substrate. So this field is nothing but coaxial field. In this coaxial field, inner conductor attached to the patch, easy to fabricate, lower spurious radiation, narrow bandwidth, difficult to model. Aperture coupled field. Here aperture coupled field will consist of microstrip line, patch and slot. Non-contacting field, most difficult to fabricate, narrow bandwidth, easier to model, moderate spurious radiation, independent optimization, feed line. Proximately coupled field. Proximately coupled field have non-contacting field, largest bandwidth, somewhat easy to model, low spurious fabrication, length of feeding sub and line fielding of control patching. Microstrip antenna feeding structure will have the equivalent circuit. Method of analysis: transmission line, cavity and full wave integral method. Transmission line model is the easiest method, will give good physical insight, but it is less accurate and more difficult. Compared to transmission line model, cavity model is more accurate but is same than complex. This will give a physical insight and difficult to model coupling, although it is saved successfully. So transmission line model will have the least occurrent result and lack of versatility. Basically, transmission line model represent the microstrip antenna by two slot separated by low impedance and transmission line of length L. Because of dimension of patch are finite along the line and the field of the edge or patch undergo fringing. This is illustrated in the figure. This applied to both. The amount of fringing is the function and the dimension. Fringing effect, it is mostly common, is the ratio of the length of the patch to the length. Since the microstrip fringing is reduced, it is taken into account because of resonant frequency of antenna. Fringing effect will be less than 1. Electric field concentrate mostly in substrate. Some of the wave travel in the substrate are taken in the air and effective dielectric constant. R effective is equal to epsilon r plus 1 by 2 epsilon r minus 1 by 2 1 plus 12 h by w whole power 1 by 2. This includes the design of transmission. So microwave strip line electric field and dielectric of proximity. Physical length and height of microstrip patch are given. Microstrip antenna transmission line model. So these are all the basic equation to design a transmission line. Del L by H is equal to 0.12 epsilon reference by 0.3 WA by H 0.24. Now epsilon effective minus 0.28 W by H plus 0.8. So you have to take the dominant mode of TM0 which is because no stringing mode. So microstrip antenna has cavity model. So most of the cavity are used in the charge distribution and current density of microstrip. The height to weight being very small attractive mechanism. Thus the tangential magnetic field to edge is significant. Consequently the four wall are modulated as PMC. This model produces E and H distribution. With the assumption lossless cavity wall and fringing dielectric, cavity wall would radiate and the input impedance should be positive reactive. This can be academic the effective tangential loss. Microstrip cavity model. Top and bottom are PEC and four side are PMC. In summary, cavity model is based on physical model. The radiation, the result of leakage and the cylindrical cavity by lateral width. Quiz question. So the application of microwave. Type of feeder in microstrip antenna. Thank you.